Alright, let's cover this problem. Max determined that the product of three linear factors, remember the word product means to multiply. Linear factors is just if I had these binomials and you had an x here and you just made up some number, -1, -1, -1. This is to the first power, so that means why it's linear. Think back to slope-intercept form, y equals mx plus b. It's to the first power, so that's what it means linear. So if I take three of them, so that should be a hint. Three of these. Thumbs down, right? Max is not right. The function f of x is equal to x squared plus x plus 2 to the power 3 is equivalent to f of x equals x to the third plus 8. Now it says explain why max is correct. So before I do why max is incorrect, I'm actually going to do the problem. So when you do a problem like this, do it. So that essentially means that you have three of these, three expressions. Raise your hand if you did that. And then I'm just going to go ahead and multiply them. Just going to multiply the first two. X plus 2, x plus 2, and we're just multiplying. X times x cost?
X squared.
Here. Here. And here. Let's combine like terms. What do you get?
X squared plus 4x plus 1.
So I've multiplied these two. Let's go ahead and multiply by the third one. So each term gets a box. And now I'm going to multiply it by x plus 2. Class, go ahead and multiply.
X cubed. 4x squared. 4x. 2x squared. 8x. 8.
Max is incorrect because x plus 2 cubed is equal to, let's combine like terms here, x cubed, you're just adding the numbers in front, 2 and plus 4 is 6. Next one. Plus 8. And the second reason why max is incorrect, cannot use power rule of exponents. I think I've shown this to you before. If the problem was something like this, 2xy to the third power. Do you see what math operation is that? It's multiplication. This is addition. Here you can distribute the 3. The math gods are okay with this. That would become 2 to the third power, x to the third power, y to the third power. This is okay. This is what the power rule is. How many x-intercepts? So this is how many times it crosses the x-axis. Does the function f of x, x plus 2 cubed have? And how many zeros explain your reasoning? So you actually don't need to use your graphing calculator for this problem because I taught you how to graph it by hand. Since you've already expanded up here, we can just apply the zero product rule. Did you guys recognize it's the same math problem 3 times? And we just subtract 2, we just do it once. And the reason why I'm writing the answer 3 times is because you set it equal to 0 how many times? So that means there are 1, 2, 3. There are 3 zeros. The answer is there are 3 zeros. Now if I graph this, -2, and let's think about it. Since I've separated it, you're not going to say a multiplicity of 1, multiplicity of 1, multiplicity of 1 at negative 2, because they're all the same number. So look back up here. The multiplicity in this problem is a 3. Is that odd or even, class? 3 is an odd or even number, class? Odd. Kiss or shoot through? Shoot through. Talk about its end behavior. This function, if you look at the a value, let's look at ours. Is that positive or negative?
Positive.
So because this a value is positive, it's going to start down and up. If it was negative, so this is positive, if it was negative, like a negative 1, it would just do the opposite, start up and down. This is your a value. So I'm just going to go ahead and put in here, something up here, and you sketch your graph. And basically when I approach negative 2, I'm going to shoot through. Class, how many times does this go through the x-axis? Once. Just goes through once. So it says how many x-intercepts are there? There's just one. One x-intercept because crosses x-axis once. How many zeros does it have? Has 3 zeros. I don't know why I keep spelling zeros with the E. Has 3 zeros. So they call that which is they call it a multiple root. So another word for x-intercepts or zeros is also roots, which is the same number. X is equal to -2. My graph is a little bit hard in the sense that, can we see a minimum or relative minimum or maximum? Maybe there. Maybe something like right there. I don't know. It's hard to see, right? Does it cross the y-axis, class?
Yeah.
So what is that called?
Y-intercept.
You have a y-intercept in the graph as well, right? So we've been talking about how to multiply linears to get a cubic function. When you are multiplying or expanding them, use your boxes. Very helpful. When you're graphing it, you can graph it by multiplicity. Multiplicity is it's in factored form, and you're looking for its degree, if it's odd or even. This is an odd, and it goes through. Remember, if it was an even, it would bounce or kiss.